So we'll discuss deletion. Here also we have a 3 cases. Case 1, I can delete a node at first position. Take assumption. This is my list. It is pointed here. This is 5. This is 10. This is 25. 100, 200, and 300. This is 300, right? This one is 200. Okay. So now I want to delete the first node. So it's very simple. Just move a head pointer to the next node. Okay, always the head is pointed in first, right? Just move a head pointer. So automatically your head node is pointed in the second position. But before that, I have to delete this node also. Okay, for that, how we can delete this one? Easily we can free this space from memory using free data type. So only that, just assign this head address to some temporary pointer. So after that, move a head pointer to the next node and then free this temp. Okay. So how we can do that? Just allocate this structure to my new node T. Next, you can assign your head address to this node. So my temp node is pointed here. Then move your head pointer to the next node. Either I can use head is equal to head of next, or T of next is also I can use, because both pointer is pointed in the same location. So 200, this is only the head of next. This is only the T of next. So head is equal to 200 means automatically your head pointer is pointed now at second position. Now easily I can delete this temp node, right? So how can I do that one? So free of T. That's it. This is deleted first node. Okay. So I want to delete the last node. Okay, this is the first case. Okay. Now this node is deleted from the list. Okay. Now the same thing, I want to delete the last node. Okay. So how can I delete the last node? So case 2, deleted last. Again, I'm going to use one traversing pointer. Why? Because I want to know which node is the last node. We know the feature, right? The last node, next value is null, is called as a last node. Which node is having the next value is equal to null, that is a last node. Easily we can do that. So for that, what do you have to do? Use one traversing pointer. Take the traversing pointer till you reach the last node. Then easily I can delete that node. Okay. Suppose you take assumption my traversing pointer is some T. Okay. That node you have to start it from the head and you have to stop at last node. So my traversing pointer is here. After that, easily you can delete this node. Okay, after deletion, your list is having still this address is available, right? That I have to remove it. Because this is only one node you are going to maintain your list after deletion of 25. So here you have to make this value is equal to null. For that, I need a 2 pointers. Okay, using single pointer, it's not possible to change the previous node next value is equal to null. I'm going to maintain a 2 pointers. Okay. So how we can do that? So struct, one pointer is for last node deletion, another pointer is for previous node, last previous node, the next value is equal to null. So I'm going to maintain T1, another one is T2. Okay. So initially I'll use a traversing pointer as T1. So I'll start it from my head node. So T1 is here. So how can I check the last node? The condition is same as the insertion, right? How we can check out? T1 of next is not equal to null means move a T1 pointer to the next node. Keep on, you have to move to the next node. So one more thing we need, right? If T1 is pointed in the second node means your T2 pointer should point at first node. So I need, if it is pointed at last means your T2 pointer should point at the last previous. Why? Because it's already I told, right? We have to make changes in this position. So for that, just I'm copying the T1 address to T1. And move where T1 pointer is equal to T1 of next. That's it. You close your while loop. Okay, two statement I used here. So now T2 is pointed here because this condition is true, right? T1 of next is 300. So it's not equal to null. Condition is true. So T2 is equal to T1 is already T1 is pointed in 200, right? Now T2 is pointed in 200 and T1 is equal to T1 of next. So T1 is equal to pointed to 300. Again the loop is executed. T1 of next it will check. What is T1 of next here? Null value. If it is not equal to null means just move a 2 pointers to the next position. But this is equal to null, so it will stop here. Now your T2 is pointed, previous last, T1 is pointed at last. Now you can delete this node easily, right? So you can use a T2, first you can change this value as a null value. So T2 of next is equal to null. So now this is erased. So this is pointed as a null value. And free this T1, right? So we can use free of T1. So this is removed from the memory. Okay. So I have 3 nodes now in my list before deletion. Using the first case, I deleted the first node. Using the second case, I deleted the last node. Now I have only one node. Okay. So we'll do the one more case. Deleted middle. Okay. So this is my list. So I have to read the position from the user also, right? Suppose I want to delete the second position node or a third position node. You can give one more node also. And 12. This is a null value. This is 400. The address of this node is 400. Okay. So I want to delete this node. Okay. This third position node. So I'm going to give a position is equal to, you have to read the position from the user. Next, I need traversing pointer also, right? So how can I delete this node is, suppose your pointed is pointed here means easily you can use one more pointer that should represent this place. Then change this address to 400 means automatically this pointed to this node. Okay, it will skip this node. Then I can delete this node. Very simple. Which node you want to, which position node you want to delete? Okay, use one pointer to point that particular position. Delete that node. But one more changes you have to do, right? The previous node should point to the next node. That particular node should not point to the already pointed node. So 300 should be erased. Here you have to place like 400 means automatically this pointed to the this node. Okay, this is only I want to delete. So how can we do that? So I need a 2 pointers, right? I'll start it from struct node star t1 star t2. So initially I'll start it with my first node. First node is head node. So head is, so my t1 is pointed where? The first node. Okay, this is a node I want to delete, right? This is a node I want to delete. Okay, next. How can I keep my pointer to this place? Otherwise, make this pointer before position. If it is position is equal to 3 means your traversing pointer t1 should point at position is equal to 2. Then easily I can do the deletion. If you are keeping here means I cannot access this node, right? So if you are keeping a traversing pointer here, easily I can copy this address. Okay, I can move this pointer to this node also. So for that, I'll go with one for loop. For I is equal to, start with 1, I less than position minus 1, I plus plus. This condition is true means just move a traversing pointer to the next node. So T1 is equal to T1 of next. Okay. Now we can start it from here. Whether the condition is true, yes. 1 less than 2. Condition is true. Okay. My T1 pointer is moved to 200. Because here 200 is there, no? So T1 is equal to T1 of next. Again, the condition is checked. So 2 less than 2. Condition is actually false. It will come out of the loop. Wherever T1 pointer is there, 200, second position, before your position. Now I can access this address, right, using T1. How can I take 300? 300 is available T1 of next. So use one more pointer, T2 pointer is equal to T1 of next. That meaning is 300 is assigned to T2. So now your T2 pointer is here. Now easily I can do, right? Just to change this address to 400. How can I change this as 400? How can I access 400 using T2? I cannot access using T1. T1 also I can use it, but easily I can track this 400 using T2. How can I access it? T1, T2 of next is 400. So I am going to allocate T1 of next is equal to T2 of next. Now this is changed as 400. That meaning is the link is erased here. This is pointed to where 400 is available. Now we can free this node, right? Easily. So free of T2. That's it. Okay. So deletion is over. Next we have a search. Okay. How we can do search? There's a fourth operation. Okay, this is my head node. 1, 10, some 20, 100. This is 200. This is also 200. This is 300. This is also 300. Okay, search is like I want to search. Before that, I have to read the which element you want to search. Okay. So element you have to read from the user. Suppose you take assumption my element is 20. I need the position also where it is available. If it is available third position, it should return to the user as a 3. If it is 2, you have to give output as 2. If it is not available means you have to give output as the element is not available in my list. Like that, I have a give a information to the user. So this is the element I want to search. You can read using scanf statement. Now, I need one traversing pointer also, right? Each position, the value have to check out. Okay. How can keep on? I have to start it from the first position to last, right? So I can give it as I is equal to 1, I less than or equal to your number of elements. Keep on increasing this n value for each insertion. Okay, the insertion we discussed, right? 3 cases. Each places initially you can give it as a 0. After that create function, you have to give it as n plus plus. After insert at first, use this one. After insert at last, use this one. Middle is also how to use this one. Okay, this statement finally, the last place you can use it. For deletion, what you have to do use? So you have to use it as a each deletion at last you can use this statement. So that I can get the how many elements available in my list. Okay, so this is you can give it as n. Only one time only each node we are going to check, right? So before that you can use one traversing pointer also. So for that I can use struct no star t. You can allocate your head node also. So t is equal to head. So initially where t is pointed here. So I want to check whether my element is there at the first position. So how can I check it? So how can I access the first field t of data? Okay, t of data is equal to element. If it is true means just use one counter variable also. Initially you can assign 0. If this condition is true means change your count variable as 1. Then use a break statement also, come out of the loop. Okay. So first time what will happen? I is equal to 1. N value is 3, right? 1 less than or equal to 3 condition is true. So it will check 1 is equal to 20. It's false, right? So again I is incremented 2 less than or equal to 3. Again it will check what is the second element you have. So before that what I have to do? T of, I didn't change my T position to the next node, right? If this is false means what I have to do? Change your T pointer to the next node also. So here you can give it as T is equal to T of next. Check this condition. If it is false means it will go here. So execute this statement. Your pointer is pointed to the next node. Again I is incremented by 1. So 2 less than or equal to 3. Condition is true. Then T of data is 10. 10 is equal to 20 will be checked. Again condition is false. So it will go here. Your T is pointed to the next node. Now it will check. Again I is incremented. 3 less than or equal to 3 condition is true again. So again it will check that 20 is equal to 20. It's true, right? Here the value is counter variable is changed as 1. It will come out of the loop also. So here you can check one condition. If C is equal to 0, use one print statement, element is not available. Else, use one more printf statement that you can give it as %d, the element available at this position. Like that you can type it. It's simple, right? If it is equal to 0 means very simple. My element is not, whatever the element you want to search, that is not available in my list. Otherwise, use a printf statement percentage %t just to print that position alone. So my element is available at this position. Okay. And one more thing we are having, right? What is that? Here you can give like this, otherwise you can give one more condition is also else. Okay, you can give it as either you can give like this, otherwise you can give it as this is up to this is over, right? Else use this statement. T is equal to T of next. Okay. So next is we are having last function is display function. Okay. How can I display function? I